so powerful that doesn't see but analyze and differentiate tissue at the molecular level. So that is an hyperspectral imaging. So I'll be exploring about the hyperspectral imaging. So what is an hyperspectral imaging? Hyperspectral imaging captures and analyzes the tissue and differentiate in a wide spectral range of wavelength. So an hyperspectral image, unlike the conventional imaging, it detect the diseases in a very early stages and also differentiate the tissue, what type of tissue it is. So you may ask the second image why I put a geographical map to compare with an anatomical structure. You know what, the first hyperspectral image was only used for remote sensing and agriculture and food quality check. To check whether the food quality is good or not, and to check the area, mineral quality, water content, that's the first hyperspectral imaging is used. Now it's currently transforming into a medical imaging diagnostics. So moving on to the working principle, and hyperspectral images capture spectral and as well as a spatial. So how it captures? By analyzing the light interaction between the biological tissues. So it generates an hypercube where each pixel contains a full spectral signatures, enabling precision identification. So every pixel has an unique spectral signature. It is also called as spectral fingerprint. So before moving on to the working, I have to clarify what is the RGB image and the hypercube. RGB image is a three broad bands, red, green and blue. Usually use camera red, it contains of the RGB color. So the three color combined and you get form an image. Whereas in a hypercube, we have many broad bands of wavelength. So we have many in a single pixel. So simply for an example, in an RGB image, take an apple, you can consider either red apple or a green apple. You can able to identify it is ripened or not. Whereas in a hypercube, you can able to identify the apple is ripened or not. Same like in a tissue. If it is appear normal in an RGB image, with the help of an hyperspectral imaging through the hypercube, you can check the tissue is an abnormal or not. So where the RGB and hyperspectral imaging comes under the electromagnetic spectrum. So from in a RGB, it lies between a 300 to 750 nanometer, whereas the hyperspectral lies between the 250 to 15,000 nm. It is near to the infrared waves. And as I said earlier, hyperspectral imaging is based upon the tissue analysis of the light interaction. So there will be a color coding given. So color coding is given to make for the physiological and pathological condition. So starting from the red color, it means eye oxygenated, which will seen in an active inflammation tumor growth. Blue and purple in a low oxygenation or a poor blood supply, which will see in a ischemic conditions. Green, usually green means normal tissue, so you will be seeing a healthy tissue. And yellow indicates a fat-rich areas, so it means you can see in a fatty liver. So white simply it's an eye reflective and dense structure. So bone calcification we can see, and black and dark blue means a low signal pickup. So we can see in a cyst or edema. So moving on to the components. So this is an hyperspectral camera. Since it is in developing, the hyperspectral camera is same, but when it move on to a different modality like CT, MRI and neurosurgery, the camera remains the same, but the prototypes may be changing. So, but the components is same as following everything. First, the light source, wavelength dispersion device, and detectors. Light is just to illuminate the tissue. So, basically, an LED light is used. And next is a wavelength dispersion device. Wavelength dispersion device is an important and essential structure in the hyperspectral image. What is it? What is function is it separates the light into different spectral of lights. So before reaching to a detector array, it converts into multispectral to form the hypercube image. So what are the types? Initially, it is used with a prism for for that what I said before, the earlier stages, but now it is grating and interferometer is currently used for medical applications. So next is the detector. The detector role is to collect the light and it convert the light signal into an image processing. So currently three types are used: CCD and indium gallium arsenide and mercury cadmium telluride. These three are used. These three are used because of the high spatial resolution and the low noise and high sensitive towards the light. So coming to how it works. So starting with, first there will be a light to shade interaction. When light to shade interaction, same, there is an absorption, scattering and autofluorescence. Autofluorescence is nothing but when a light is interact with the tissue, it gets converted into heat and another it gets reflected back. That the property is called as autofluorescence. Next, the step is spectral signature detection. So each and every tissue, that's a different types of tissue have different spectral signature detection, which is further helpful in to form the hypercube. So third is an hypercube formation. Hypercube is an 3D data set where we have a spectral and spatial resolutions. So then is a image processing, and finally we will be classifying and diagnosing based upon the image we get. So how the working? First, the light is illuminated in the tissue, then it moves to the front lens, and then it forms to a slit. Then a collimator makes into a narrowing, and what happens? It go into the dispersion device, grating or a prism, or there will be a light is split into multiple, and then with the help of a focusing lens, it goes to the detectors, where there will be the final image we will be getting. So first you can see the foot, we will be giving a light to illuminate, and next the RG image, that's a normal image. Then with the help of the RG image, we have many functions. First is an NR coefficient index, next is an oxidation saturation, and third is organ hemoglobin index, and tissue water index and tissue lipid index for the tissue composition. And next, what are the medical applications currently hyperspectral imaging? Cancer diagnosis, early detection, and what are the staging of a cancer, cardiology for ischemic conditions, and surgical guidance. We can do a live surgical guidance with the help of this hyperspectral image, because we have to eradicate the cancer cells rather than the healthy cells. So for that, this hyperspectral is commonly used, and histopathology and wound assessment to for certain the burns and wound assessments, everything. And pharmacology, how the tissue is reacted to the specific drugs which we have given. So advantages, the main advantage is non-invasive, non-annexing, early disease detection, enhanced tissue differentiation, real-time imaging, functional molecular insights, no need for quantization. As now the current world is adapted to AI, this spectral imaging also adapted with AI. And these are the cases. The first image is a flap insert surgery. The patient has a stage 4 squamous cell carcinoma in the mandible. So the region is completely removed and the flap is inserted. You can see the oxygenated image and the NI to confirm that the correct cells has been removed and correctly placed. And this is a Crohn's disease. First is a CT image, next is an hyperspectral image. Some may confuse it is a spectral CT. Now spectral CT and hyperspectral are same, but what happens, spectral we have in a dual energy, whereas hyperspectral we have multiple wavelength of bands will be used. So conclusion, hyperspectral is currently developing in a medical field, recently developed in 6 to 5 years. Yes, it has a limitation in the data processing and previous unit, everything. So if further development, it will be reaches to a higher, greater need. And what happens if the development is good, and we will be developing a higher accuracy of imaging modality. And these are the reference which I took this content, and I end up here. Thank you. Thank you, organization committee, for this opportunity.